Hi gang, so there's something I never really showed you, what would happen if all of a sudden I took a rational function and then threw this little constant on over here, how that would impact the graph. But if you go back to what a rational function looks like, it's interesting because we always look at what's going to cause your denominator to equal 0 because we're always on the hunt for our domain restrictions. So over here, if you guys take a look, you have 1 minus 2x. And again, if you're trying to figure out what the domain restriction is, you would simply set the denominator equal to 0, and you're like, oh, x can equal a half. So you know your domain is going to be all reals where x cannot equal 1/2. And we should all know that that's also going to be our vertical asymptote when we go to graph it. Now, what's really interesting is that the horizontal asymptote all this time has always been y equals 0. But my thing is if I start putting in giant values in here for x, right, no matter what, this ratio is going to go to 0, so I'm always going to be left with a 3. So the bigger x gets, the smaller this entire ratio gets, and I'm kind of left with a 3 here. So this constant over here kind of acts like, and it tells you that that's going to be your, you guessed it, my friends, the horizontal asymptote. So therefore, my domain is going, I'm sorry, we know what my domain is. My range is going to be all reals, but where y cannot equal 3. So when we go to get a little quick sketch for this graph, we know that we have a horizontal asymptote at a half, right? This blue pen is just gorgeous. Look at how pretty this color is. I am enjoying writing with it. And then over here we have y equals 3. So we're broken down into these like dotted lines of quadrants, right? So here, 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 here. So it's like the graph is going to be here and or here, or it's going to be up here or down there. It can't be in both like the first and the fourth, because then it wouldn't pass the vertical line test and it wouldn't be a function. And this is a function. So anyway, I always enjoy starting with 0. 0 is my best friend. So when I plug 0 into this function, this term goes away and I wind up with a 1 over 1, which is 1. But don't forget to add the 3, which is 4. So over here, I am at 0, comma 4. Now be careful. 0, comma 4 is actually above this horizontal asymptote. So it's actually going to be up here, which means our graph is going to be going like this, because remember, your curve is always trying to get to your asymptotes but never quite gets there. Okay? Now, the other thing is that we can pick a point to the left of a half to see if we're up here or if we're down here. So I can plug in a 1, because 1 is right after that. So if I plug in 1, I get 1 over 1 minus 2 times 1 plus 3. Right, so I get 1 over 1 minus 2, so that's negative 1, so I get negative 1 plus 3, which is equal to 2, and 2 is somewhere over here, so 2 is going to put us in here, so we know our graph is going to look like that. So we've got our hands on our rational function, because once we know what the general idea of what a rational function is, we can go ahead and do what it is that we need to do. Now, I want to get the general slope here, and the general slope is going to be a little more interesting, and I'm probably going to be like, oh, I need new paper, because it's going to get a little more arduous because of this term right over here. This term is going to kind of mess things up for us, but not really. Nothing we can't handle, because we are BAMs, right? B-A-M. That's what we are. We are badass mathematicians. Okay, so anyway, moving on here, if I want to do my f of x plus h, my f of x plus h is going to be 1 over 1 minus 2x minus 2h, because I remembered to send the negative through, okay, plus a 3. So that's the actual, this is f of x plus h is this whole thing. So now when I do it, my general slope, I'm going to call GS my general slope, I have 1 over 1 minus 2x minus 2h plus 3 minus my 1 over 1 minus 2x, plus 3 over here, but that whole thing is a plus, and that's going to be all over h. So I want to point something out. I want to point something out, and I want you guys to point something out too. The interesting thing is, if I distribute this negative sign through right now, I can make the 3's go away, and then it just goes back to the basics. These are the kinds of things I want to keep you knuckleheads aware of making your lives easier when you're dealing with certain things like this. So I'm telling you now, that's what I'm going to do. And if you don't do it, well, you're just basically setting yourself up for, trouble. So my general solution then, so I would have 1 minus 2x minus 2h, and then that 3 is going to cancel out with that 3. So I'll even go through the motions, and then that's all I'm going to do on this particular video, because it's going to be 1. So now this is negative 2x, and then minus 3 all over h indicates to me that I sent the negative through both of these, so now I can cancel those two out. And now I'm in business because I'm back to what we've been doing before when we would do our 1 minus 2x minus 2h minus 1 over 1 minus 2x all over h, and then multiplying the top and bottom by the common denominator and doing our usual shenanigans. That was just a little thing I wanted to show you there. Now, I also want to do it with a square root function to see how we would actually handle a square root function. And the question again is, would it be the same thing? And the answer is likely. Okay, so if I were to do f of x is equal to the square root of, I just hit something on here. Okay, so let's say 1 minus 2x plus 7. Okay, so again, I don't know why I'm obsessed with this 1 minus 2x, but I am. But remember, when you're dealing with a square root function, your goal is to make sure that the inside is positive. So we take the inside and we go off to the side and we do 1 minus 2x is greater than or equal to 0. Subtract 1, I get negative 2x is greater than or equal to, negative 1. Divide both sides by negative 2. And if you recall, when you divide by a negative, you switch the inequality sign. So we now know that x is less than or equal to 1/2. Now, the interesting thing is there's this cute little plus 7 sitting on over here. So the thing is now this number right here almost gives us something interesting to find. So I know if I were to plug in a table 1/2, and if I were to plug 1/2 into this function, can you knuckleheads please tell me what you're going to get for your y value? You got it. You're going to get 7. Because 1 minus 2 times 1/2, that's 0, and then that comes out to equal 7. So now, since x is less than or equal to 1/2, because that is in fact our domain, that means the next number we can pick could be 0. So if I go ahead and plug 0 into this function, I'm going to have 1 minus 0. This is going to be 0. So this is the square root of 1, which is 1. Don't forget to add the 7, so that's going to be an 8. And then the next thing is since I'm going in the opposite direction, I could make this a negative 1, okay? So if I were to plug in a negative 1 in here, I would have 1 minus 2 times a negative 1. Those two negatives make a positive, so this winds up being 1 plus 2, which is the square root of 3, but plus 7 on the end there, okay? So this is going to be about, now, the square root of 3 is about 1.73, and so therefore this is going to be 8.73, okay? If I plug in a negative 2, this is going to give me a square root of 5 plus 7. Square root of 5 plus 7. Square root of 5 is about 2.2. I don't know. It's somewhere around 2.2. Plus 7 would be 9.2. So as you can see, as I keep plugging in x values, my y values are growing a little bit by a little bit. So when I go to graph this little crooked line that I have over here, I'm over here at 1/2, but at 1/2, I'm not on the x-axis. I'm actually up here at 7. So I'm at 1/2 comma 7. And everything, my x values are going to the left and my y values are growing along here, right? And I know that this point here is 0, 8, because that's what my table's telling me. So therefore, it's going to look like this. So therefore, my domain is going to be x is less than or equal to 1/2, but my range is y is greater than or equal to 7, okay? So these are the kinds of things that I want you guys to think about. So now, when I go ahead and I want to find out what the general slope is for this guy, again, we do our f of x plus h here, so that's equal to the square root of 1 minus 2x minus 2h, because I know how to distribute a negative through. So when I do this, and I do my general slope of 1 minus 2x minus 2h plus 7, minus the quantity of the square root of 1 minus 2x plus 7, all over h. Again, if you distribute the negative through here, you make the 7s go away, and that's exactly what I want you guys to see. So I'm actually running out of paper, so I can go to the other side of this because I can. So when you do distribute that through, you do wind up with your square root of 1 minus 2x minus 2h plus 7 minus the square root of 1 minus 2x minus 7 all over h. And then you would just cancel out your 7s, and now you have your basic conjugate problem where you're going to multiply top and bottom by this over that plus that, which is that gorgeous form of 1. Now, there is one more thing I do want to show you, okay? These are just good things to keep in mind. Let's say I have this quadratic function 1 minus, say, 3x squared over 4, okay? So I have this quadratic function, and let's say that I want to get the general slope between the 2 points, right? So for starters, You knuckleheads can look at it this way, that this is 1/4 minus 3x squared over 4, because you can go ahead and break it down that way. And you should notice that this is a parabola that opens down, okay? And we'll find out why your vertex is at 0, 1/4 at some point very soon. So your graph is going to look like this. So if I want to do my g of x plus h is equal to 1 minus 3 times x plus h squared all over 4, I'm going to have something like that. And then I would totally multiply this guy out. So your x plus h squared is equal to your x squared plus your 2xh plus your h squared and so forth, right? So now g of x plus h is equal to 1 minus, I'm going to distribute the 3 through this too. So 3x squared minus 6xh minus 3h squared all over 4. Okay, and that's what my g of x plus h is. So now when you go to do, and if you have to, like go off and do this off to the side to make sure that you get what I get. So when we do the slope between these 2 points, we get 1 minus 3x squared minus 6xh minus 3h squared, right? Then it's going to be minus, I'm sorry, and that's all over 4, right? And that's going to be minus the quantity of 1 minus 3x squared all over 4, and that's all going to be all over h, because that's how we find the general slope between 2 points. Now, the interesting thing is again, you have these stupid, like 4 in the denominator, right? So the question is how do we make this easier for ourselves? Well, to get rid of these 4s immediately, multiply top and bottom by 4 over 4. Because this is technically 4 over 1 times 4 over 1. And when we have the 4 over 1, we're multiplying that times that, which is going to make this go away. And that times that is going to make that go away. And then we just multiply that by a 4. So when I do this, multiply this times this term, the 4's cancel. And I'm just left with 1 minus 3x squared minus 6xh minus 3h squared, right? If I multiply this times this, those cancel out. And then if I distribute my negative sign through, because I can multitask, right, I get this. And then it's going to be all over 4h. So the beauty of multiplying this by 4 over 4, AK1, is it makes this a hell of a lot easier to solve out. So then our usual things happen where these guys cancel, and I'm left with a negative 6xh minus a 3h squared all over a 4h. And then at this point, you knucklehead should be like, oh, I can factor out an h, negative 6h minus a 3h all over 4h, cancel, cancel, and then your general slope would be negative 6x minus 3h all over 4. So just little things to keep in mind as we continue to embark throughout the year, because throughout the year when we visit different families of functions, we are going to start seeing this stuff again, and we're going to want to employ that fantastic algebra. Okay? Hope this was helpful.